morning, students. Welcome to your chemistry class. Let us further discuss the chapter Structure of Atom. And the objective of our today's topic will be Quantum Theory of Radiation. In our previous lecture, we have studied what are electromagnetic radiations. And now we are going to start our topic with the same, that is electromagnetic wave theory was able to explain us refraction, refraction. The first two are reflection and refraction. Now what is this reflection? Reflection is bouncing back of light after striking the reflecting, that is a hard surface in the same medium. Supposing the medium is air, then the bouncing back of light will be in the air. The next one is refraction. Refraction means the change in path of light when it travels from one transparent medium to another. And you are very much familiar with this, that in refraction, the light bend towards the normal and it change its path as well. Now the third one is that the electromagnetic wave theory was able to explain was diffraction. Diffraction is the bending of light around corners such that it spreads out and illuminates areas where a shadow is expected. So we can see the light travels like a wave and then it actually passes through the slits and illuminates the area. The fourth property that the electromagnetic wave theory was able to explain was interference. Interference is the phenomenon in which two waves superimpose. Supposing there is a wave coming from one slit, then it is passed from two slits and accordingly it superimposes into each other and then they form the resulting wave of the lower, higher or same amplitude. So the waves are superimposing into each other and this gives rise to constructive or destructive interference. So these four properties electromagnetic wave theory was able to explain. But then comes the limitations. What the electromagnetic wave theory was not able to explain. First one is black body radiation. Now what is this black body radiation? The radiations emitted by the black body is called black body radiations. Now black body is a perfect absorber and perfect emitter of the radiant energy. But this was not been explained by electromagnetic wave theory, that why this is happening. So supposing in the classical mechanics, supposing an iron rod is being heated, then what was observed was that it first become red, then yellow and then white. According to electromagnetic wave theory, the energy is absorbed or emitted by a body continuously. Thus, the energy of electromagnetic radiation is directly proportional to its intensity. That means it is independent of the frequency and wavelength of the radiation. That means the body should emit radiation of same wavelength, that means same color. But why we observe three different colors when it is being heated, when a body is heated? Why this happens? So the explanation to this was being given later. Okay, so we will be discussing about its explanation also in the coming class. The next limitation of electromagnetic wave theory was the photoelectric effect. Now what is photoelectric effect? It is a phenomenon in which the electrons are ejected from the surface of a metal when they are irradiated by light or any radiation with a suitable frequency. So this was also not been explained by electromagnetic wave theory, that why this was happening, that why electrons were ejected when a light irradiates on a metal surface. The third one was the line spectrum of hydrogen. So the electromagnetic wave theory was not able to explain the line spectrum of hydrogen also, that why so many lines are being observed. To overcome this, then there comes a new theory, that is quantum theory of radiation. It was given by Max Planck in 1901. So in order to explain black body radiation and photoelectric effect, Max Planck came up with quantum theory of radiation. The main points are as follows. The first one is that the hot body emits radiant energy not continuously but discontinuously in the form of small packets of energy called quantum. That is, in case of light, the quantum of energy is often called photon. That means instead of a wave, that is radiation is a wave, it will have a particle-like characteristic, that is it is coming in small packets. The second point was that the amount of energy associated with quantum of radiation is directly proportional to the frequency of the radiation. So E is directly proportional to nu. That is, the amount of energy is directly proportional to the frequency. To remove this proportionality sign, we need to introduce a constant, and the constant is h, that is Planck's constant, where h is Planck's constant. So now we have a formula, E is equal to h nu. And the third point of this theory says that the energy emitted or absorbed by a body can be either one quantum or any whole number multiple of h nu. That is 2h nu, 3h nu, 4h nu, and so on. So thus the energy emitted or absorbed is equal to E is equal to nh nu. So where n can be 1, 2, 3, 4, and so on. Now the different forms of quantum energy, that is how we can represent this energy in different forms. The first was that E is equal to h nu. Now as we know that the frequency equals to c upon lambda, that is velocity of light upon wavelength. Now if we rearrange the terms and substitute this c by lambda here, then we can get E equals to hc by lambda. So we can rearrange and we can find wavelength also with the same. So this will be used in numerical problems. Now as we know that nu bar, that is your wave number, is equals to 1 upon lambda, that is wavelength. Therefore when we substitute this in the previous formula, it becomes E is equal to hc nu bar, that is h is your Planck's constant, c is velocity of light, and nu bar is your wave number. So if in a numerical problem they ask you to calculate wave number, so it will be wave number equals to E upon hc. So with the help of quantum theory of radiation, black body radiations were explained. So the explanation was that when a metal of high melting point is heated, its atoms vibrate and emit the radiation of frequency nu. Frequency of emitted radiation increases on further heating the body. That means the object is taking up heat one by one, and simultaneously it is emitting heat also in the form of radiations, and that radiations are of different wavelengths, and it changes the color from red, yellow, and then as the frequency increases it goes till blue. So students, in our today's class, we have studied limitation of electromagnetic wave theory, and to overcome that theory, quantum theory of radiation came into consideration. Thank you so much for today.